what happens? What's a 2D discrete convolution? What's a 2D discrete convolution? Now you might say, okay, why is Professor Strang inventing these problems? Because a 2D discrete convolution is the core idea of image processing. If I have an image, what does image processing do? Image processing takes my image, it separates it into pixels, right? That's all the image is, a bunch of pixels. Then many 2D image processing algorithms will take JPEG, old JPEG for example, would take an 8 by 8, 2D in other words, 8 by 8, 2D is the main point, set of pixels, and transform it, do a 2D transform. So what is a 2D transform? What would be the 2D transform that would correspond to this? First of all, how big's the matrix? Just so we get an idea. I probably won't get to the end of this example. But just, so in 1D, my matrix was 4 by 4. Now I've got, so that was for 4 points on a line. Now I've got a square of points. So how big is my matrix? 16, right? 16 by 16, because it's operating on 16 pixels. It's operating on 16 pixels, where in 1D it only had 4 to act on. So I'm going to end up with a 16 by 16 matrix here. And I think, let me see, what do I need? Oh, wait a minute. Uh-oh. Yeah, I think time's up here. Yeah, because my C, has my C got to have 16 components? Yes. My U has to have 16. My right-hand side has got these 16 components. Yeah, so I'm up to 16, but a very special circulant of a circulant. It'll be a circulant of a circulant somehow. Okay, enough for 2D. I'll see you Wednesday, and we're back to reality. Okay.